In a groundbreaking announcement, Elon Musk has unveiled a revolutionary new water engine that promises to transform the future of transportation and energy. After years of skepticism and countless innovations, Musk's latest venture sets the stage for unprecedented environmental sustainability. But what makes this water engine so unique, and how will it impact our world? These questions form the basis of an exciting exploration into the mechanics of Musk's incredible invention and the far-reaching implications of this game-changing technology. Elon Musk abruptly announced a major shift in Tesla's direction on X, formerly known as Twitter. In an unexpected turn of events, and after years of expressing doubt regarding hydrogen fuel cells, Musk declared that Tesla would transition from battery power to hydrogen power, marking a significant shift in the company's business plan. This announcement surprised many, given Musk's earlier criticisms of hydrogen fuel cells, which he famously referred to as fool cells. The decision to pivot was driven by challenges in mass-producing the 4,680 battery cells, prompting Tesla to reassess its sustainable energy strategy. Musk revealed that at the forefront of this transition would be Tesla's latest innovation, the revolutionary water engine. This groundbreaking technology promises to redefine the concept of engines, offering unparalleled environmental benefits and performance. With this development, the question arises, what makes this water engine so revolutionary, and how will it impact the automotive industry and beyond? Elon Musk, the visionary behind Tesla and SpaceX, has always been driven by a commitment to cutting-edge technology and environmental sustainability. His goal is to create a future where technology enhances lives while protecting the planet. Musk's relentless pursuit of innovation has consistently pushed boundaries, earning him a reputation as a modern-day pioneer. His vision for Tesla was never just about creating electric cars, but about transforming the entire automotive industry. He aimed to prove that electric vehicles could be faster, safer, and more enjoyable to drive than their gasoline counterparts. This mission extended beyond cars, as it sought to accelerate the world's transition to sustainable energy. Beyond Tesla, Musk's ambitions with SpaceX have reached into outer space. He has worked to make space travel more affordable and accessible, ultimately aiming to colonize Mars. SpaceX's achievements, such as successfully landing and reusing rockets, have revolutionized the space industry and demonstrated Musk's ability to turn ambitious dreams into reality. Musk's journey in renewable energy and transportation is marked by significant milestones. Tesla, founded in 2003, initially faced skepticism, as electric cars were often considered impractical and inefficient. However, Musk's perseverance paid off with the launch of the Roadster, Tesla's first vehicle, which showcased the potential of electric cars through its impressive performance and range. Subsequent releases of the Model S, Model X, Model 3, and Model Y solidified Tesla's leadership in the electric vehicle market, with each model introducing advancements in battery technology, driving range, and autonomous driving capabilities. These innovations made electric cars increasingly viable for everyday use. Musk's contributions extend beyond vehicles to renewable energy solutions. Tesla's Powerwall and solar roof products create a sustainable energy ecosystem for homes and businesses, integrating solar energy generation with efficient energy storage. This approach provides practical solutions for reducing dependence on fossil fuels. In the realm of space travel, SpaceX has achieved remarkable milestones, such as the Falcon 9 rocket's ability to land and be reused, dramatically reducing the cost of space missions. The successful deployment of the Starlink satellite constellation, aimed at providing global internet coverage, highlights Musk's far-reaching impact on technology and innovation. The water engine operates on a simple yet ingenious principle: it uses water to generate energy. This process fundamentally separates it from traditional combustion engines, which rely on burning fossil fuels, and from electric engines that depend on battery power. At its core, the water engine utilizes a method called reverse electrolysis. In conventional electrolysis, electricity is used to split water, HO, into hydrogen, H, and oxygen, O. In reverse electrolysis, the process is flipped: hydrogen and oxygen are combined to produce electricity, and the only byproduct is water vapor, making this an exceptionally clean technology. The mechanics of the water engine are a blend of fuel cells, reverse electrolysis, and hydrogen-oxygen reactions. Initially, water is introduced into the system, and the engine splits it into hydrogen and oxygen using an initial energy input. These gases are stored in separate tanks within the vehicle. When the engine operates, hydrogen is fed into the fuel cell, where it is split into protons and electrons. The electrons create an electric current to power the vehicle's electric motor, while the protons move through a membrane and combine with oxygen from the air, producing water vapor as the only emission. This process is incredibly efficient, continuously generating electricity as long as hydrogen and oxygen are available. The water engine's efficiency, when compared to traditional and electric engines, represents a remarkable leap forward in sustainable transportation technology. The answer is quite promising. Traditional combustion engines have an efficiency rate of about 20 to 30%, meaning a significant amount of energy is lost as heat. Electric engines, while more efficient at around 85 to 90%, still face challenges like long charging times and battery degradation. The water engine, however, boasts an efficiency of approximately 60%, placing it between combustion and electric engines. More importantly, it offers a cleaner, more sustainable alternative. Another critical performance metric is range. Traditional electric vehicles, EVs, often suffer from range anxiety, with current models typically offering between 200 and 300 miles per charge. The water engine, leveraging the high energy density of hydrogen, can achieve ranges comparable to or even exceeding those of fossil fuel-powered vehicles. Imagine driving a car that emits only water vapor and never worrying about running out of power in the middle of a trip. What makes the water engine so unique is its ability to refuel quickly, similar to gasoline vehicles, unlike electric vehicles that require lengthy charging sessions. This convenience, combined with its environmental benefits, positions the water engine as a game-changer in the automotive industry. One of its most significant advantages is its potential to drastically reduce our carbon footprint. Traditional combustion engines emit large amounts of carbon dioxide and other pollutants, contributing to climate change and air pollution. In contrast, the water engine produces only water vapor as a byproduct, making it an exceptionally clean alternative. To put this into perspective, the average gasoline-powered car emits about 4.6 metric tons of carbon dioxide annually. Transitioning to water engines could eliminate these emissions entirely. Moreover, the elimination of nitrogen oxides and particulate matter would lead to significant improvements in air quality, particularly in urban areas. Comparatively, electric vehicles, EVs, are also cleaner than fossil fuel-powered cars but are not without environmental costs. The mining of lithium, cobalt, and other rare earth metals required for batteries has substantial ecological impacts. Additionally, if the electricity used to charge EVs is sourced from non-renewable power plants, the overall reduction in carbon emissions is less pronounced. Hydrogen fuel cells represent another clean alternative, producing only water as a byproduct. However, the production of hydrogen typically involves natural gas, resulting in indirect carbon emissions. Additionally, hydrogen storage and transportation pose challenges due to its low energy density and the need for high-pressure tanks. The water engine, utilizing reverse electrolysis, has the potential to offer a more efficient and environmentally friendly solution. By using renewable energy sources to produce hydrogen, the entire life cycle of the water engine becomes sustainable, further reducing its environmental footprint. Economically, the water engine could bring substantial cost savings in the long run. Traditional internal combustion engines require regular maintenance, including oil changes, exhaust system repairs, and engine tune-ups, which can be expensive over time. Electric vehicles have fewer moving parts, reducing maintenance costs, but still require battery replacements, which can be costly and environmentally taxing. The water engine, with its simpler mechanics and fewer moving parts, promises even lower maintenance costs. Components like fuel cells and electrolysis systems are designed for durability, potentially extending the lifespan of vehicles. As the technology matures and economies of scale are realized, the initial cost of water engine vehicles could decrease significantly, making them more accessible to the average consumer. However, the transition to water engines will require significant initial investment. Developing the infrastructure for water refueling stations is a massive undertaking. This involves either building new stations or retrofitting existing ones to accommodate water refueling technology. The cost and logistics of establishing a widespread network of refueling stations will require substantial collaboration between governments and private companies. On a broader economic scale, the adoption of water engines could reduce global dependence on oil, leading to more stable fuel prices and potentially reducing geopolitical tensions linked to oil supply. This shift could stimulate job creation in new industries focused on water engine technology, manufacturing, and infrastructure development. The introduction of the water engine represents a significant technological shift in the automotive industry. Transitioning from combustion engines and electric vehicles to water engines involves overcoming various challenges. The current automotive infrastructure is fully rooted in fossil fuels, from manufacturing processes to refueling networks. To address these challenges, companies can leverage existing technologies and expertise. For example, many principles from hydrogen fuel cell technology, such as fuel cell design and hydrogen storage, can be applied to water engines. This can facilitate faster development and deployment of the new technology. The future of Musk's water engine raises compelling questions. Will it redefine our approach to energy and transportation, or will it face insurmountable obstacles? The automotive industry has watched Musk's announcement with keen interest. Major players like Toyota and Hyundai, longtime advocates of hydrogen fuel cell technology, have had mixed reactions. Toyota, for example, has invested heavily in hydrogen fuel cells with vehicles like the Mirai, while Hyundai has introduced models like the Nexo. Toyota's executives view Musk's core concept as a validation of their long-standing belief in hydrogen's potential. The announcement of water engine technology has sparked diverse reactions from various quarters. Some view it as a positive step towards broader acceptance and investment in hydrogen infrastructure. Hyundai remains cautiously optimistic, acknowledging the competitive push while recognizing the significant market development required to support both hydrogen and water engine technologies. Analysts and industry specialists have extensively discussed the feasibility of water engines. While some see it as a groundbreaking innovation that could accelerate the transition to sustainable energy, others express skepticism, citing real-world challenges. These include questions about the technology's efficiency, the infrastructure needed for water refueling, and the economic viability of widespread adoption. Public reactions to the announcement have been a mix of excitement, curiosity, and skepticism. Social media has been abuzz with discussions, as followers of Elon Musk and Tesla enthusiasts express their anticipation for this new technology. Many are intrigued by the promise of a cleaner, more efficient engine and its potential environmental benefits. However, concerns persist. Critics point to Musk's previous criticisms of hydrogen technology and question the feasibility of a rapid transition to water engines. There are worries about the practicality of building a new refueling infrastructure and the initial costs associated with adopting this technology. This raises a fundamental question: will Musk's water engine truly prove to be the game-changer it promises? One of the most significant challenges in deploying water engine technology is the development of a comprehensive refueling infrastructure. While traditional fossil fuel infrastructure is extensive, with gas stations present globally, and electric vehicle (EV) charging networks are rapidly expanding thanks to investments by companies like Tesla, hydrogen fuel cell infrastructure is still in its infancy. Currently, there are relatively few hydrogen refueling stations, mostly concentrated in regions such as California, Japan, and parts of Europe. For water engines, which rely on a similar hydrogen-based refueling process, this network provides a starting point, but substantial expansion is essential. Tesla aims to address this by retrofitting existing EV supercharging stations with hydrogen refueling capabilities and constructing new stations specifically for water engines. However, this ambitious plan demands significant investment and collaboration with governments and private partners. The pace of establishing this network and overcoming logistical and financial hurdles will be critical as Tesla moves forward with its water engine rollout. Safety is another paramount concern in introducing new technology. Hydrogen, while a clean energy source, is highly flammable and requires careful handling. Water engines, relying on hydrogen, inherit these safety challenges. Tesla has implemented several safety measures to address potential risks, including advanced hydrogen storage systems designed to withstand high pressure and prevent leaks. These systems, along with rigorous testing procedures, aim to meet and exceed international safety standards. By prioritizing safety at every development stage, Tesla seeks to ensure the water engine's reliability and security. Nevertheless, public concerns about safety remain, prompting questions about what additional steps might be necessary to establish the technology as both safe and trustworthy. Navigating the complex legal and regulatory landscape presents another significant challenge. Different countries have varying regulations regarding hydrogen production, storage, and transportation, adding complexity to the global rollout of water engines. Tesla has proactively engaged with regulatory authorities worldwide to ensure compliance with all relevant standards. This involves extensive documentation, rigorous testing, and ongoing dialogue with regulators to address concerns and adapt to evolving requirements. These efforts are crucial for overcoming regulatory hurdles, but specific challenges in different regions remain a question. Tesla's proactive approach will likely influence global adoption, but the extent of its success will depend on navigating these regulatory landscapes effectively. Each sustainable technology has its strengths and challenges. Hydrogen fuel cells offer high energy density, enabling long driving ranges and quick refueling, while emitting only water vapor, making them environmentally friendly. However, challenges such as producing, storing, and transporting hydrogen gas, which requires specialized infrastructure, persist. Water engines present a notable advantage through on-demand hydrogen production, simplifying storage and reducing risks associated with hydrogen gas handling. This method can integrate well with renewable energy sources, enhancing sustainability. Nonetheless, the reverse electrolysis process involved in water engines requires significant initial energy input, potentially affecting overall efficiency. The market potential for water engines is promising but faces challenges. The automotive industry is keen to reduce carbon emissions and adopt sustainable energy sources. Governments worldwide are setting strict emissions targets and providing incentives for clean energy technologies, creating a conducive environment for innovation. Analysts suggest that water engines could gain significant market share within the next decade if Tesla can resolve efficiency and infrastructure issues, scale up manufacturing, and ensure widespread deployment. Partnerships with public and commercial sectors will be essential. However, questions remain about what it will take for water engines to revolutionize the transportation industry and how they will compete with established technologies while navigating the evolving sustainable energy landscape. The evolution of engine technology has always been driven by innovation. The journey began with the invention of the steam engine in the late 17th century, with figures like Thomas Newcomen and James Watt improving its design and revolutionizing transportation and industry. Today, the water engine represents the latest step in this ongoing evolution, with its success hinging on addressing technological, infrastructural, and regulatory challenges. These early engines were crucial in driving the Industrial Revolution, powering locomotives, ships, and factories. By the late 19th century, the internal combustion engine emerged, developed by inventors like Nicholas Otto and Rudolf Diesel. Otto's four-stroke engine and Diesel's compression ignition engine became the foundation for modern gasoline and diesel engines. These engines offered greater efficiency and power, leading to their widespread adoption in automobiles, aircraft, and ships. The 20th century saw significant refinements in internal combustion engines with advancements in materials, fuel injection systems, and turbocharging. These improvements enhanced performance, fuel efficiency, and emissions control, making internal combustion engines the dominant force in transportation. As concerns about pollution and fossil fuel depletion grew, the search for alternative fuel engines intensified. By the late 20th and early 21st centuries, electric vehicles, EVs, began to gain traction, with companies like Tesla, under Elon Musk's leadership, spearheading the EV revolution. Advancements in battery technology, range, and charging infrastructure played a crucial role in this progress. Before Musk's water engine, there had been numerous attempts to develop alternative fuel engines. One notable effort was the development of hydrogen fuel cells in the 1960s. NASA used hydrogen fuel cells to power spacecraft in the Apollo missions, demonstrating the technology's potential. However, commercial adoption faced significant hurdles, including challenges in hydrogen production, storage, and infrastructure. Another notable attempt was the development of biofuel engines. In the early 2000s, there was a surge in interest in biofuels such as ethanol and biodiesel derived from plants and organic waste. While biofuels offered a renewable energy source, their production required large amounts of agricultural land and water, raising concerns about food security and environmental sustainability. Electric vehicles also represent a major shift in engine technology. Early EVs, such as General Motors EV1 in the 1990s, showcased the potential of electric propulsion. However, limited range, high costs, and inadequate charging infrastructure hindered widespread adoption. It wasn't until advancements in lithium-ion batteries and the establishment of extensive charging networks that EVs began to thrive. The history of alternative fuel engines offers valuable lessons that inform Musk's current project. One key lesson is the importance of infrastructure. Hydrogen fuel cells and early EVs struggled with infrastructure challenges, and Musk's plan to leverage Tesla's existing supercharger network for hydrogen refueling addresses this critical barrier. Another lesson pertains to energy efficiency. Despite being renewable, biofuels frequently used more energy during production than they produced. Musk aims to maximize energy efficiency by focusing on reverse electrolysis in the water engine, ensuring that the process of splitting water and recombining hydrogen and oxygen is as effective as possible. Musk's water engine represents the latest evolution in the ongoing quest for cleaner, more sustainable engine technology. By building on the successes and learning from the challenges of past innovations, Musk is pushing the boundaries once again. A number of businesses and innovations could compete with Tesla's water engine. The Nikola Corporation, specializing in trucks powered by hydrogen, has made significant strides toward creating heavy-duty vehicles that run on hydrogen fuel cells, despite numerous setbacks. Their emphasis on the business market may provide Tesla with fierce competition, particularly in long-distance travel. BMW is also exploring hydrogen fuel cell technology, having unveiled prototypes and committed to further research. With their strong brand and engineering prowess, BMW could present a formidable challenge to Tesla's water engine, especially in the luxury vehicle market. Rivian, an electric vehicle startup backed by major investors like Amazon and Ford, represents another competitive force. While Rivian currently focuses on electric vehicles, their innovative approach and substantial funding could enable them to pivot toward water engine technology if the market demands it. Collaboration is essential for the quick development and widespread adoption of water engines. Tesla has a track record of establishing tactical alliances to further its technological objectives. Partnerships with top tech businesses, universities, and research organizations can provide access to cutting-edge research, specialist knowledge, and advanced technology. Collaborations with universities focused on hydrogen research could help Tesla refine the efficiency and performance of its water engine, while partnerships with tech giants like Google or Apple could integrate advanced software and AI capabilities, enhancing the overall functionality and user experience of water engine vehicles. The smooth integration of water engines with renewable energy sources like solar and wind power is one of its most exciting features. Utilizing electrolysis to create hydrogen using renewable energy, Tesla's collaborations and innovations could reshape the future of transportation. Will these partnerships pave the way for the widespread adoption of water engines? Only time will tell. The water engine operates with minimal carbon emissions, producing hydrogen in an environmentally friendly manner. This process involves splitting water into hydrogen and oxygen using electricity generated by renewable energy sources such as solar panels or wind turbines. Envision a scenario where homes equipped with solar panels generate hydrogen fuel during the day, which can then be used to power water engine vehicles. Similarly, wind farms could provide electricity for the grid while producing hydrogen for transportation, creating a synergistic relationship between renewable energy generation and sustainable transportation. The potential impact on the energy grid could be transformative, as hydrogen production can act as a form of energy storage. Excess energy produced during peak periods can be captured and later converted back to electricity or fuel during high-demand times. This ability to balance supply and demand could stabilize the grid and enhance the reliability of renewable energy sources, even when natural conditions fluctuate. The widespread adoption of water engines could significantly advance global sustainability initiatives. By transitioning away from fossil fuels, water engines can drastically lower greenhouse gas emissions and reduce air pollution, leading to a healthier planet, cleaner air, and improved community well-being. This shift also aligns with the overarching goal of decarbonizing the energy system. Integrating water engines with renewable energy sources can accelerate the transition to a fully sustainable energy environment, promoting the use of green hydrogen and encouraging the development of hydrogen infrastructure. These combined efforts could drastically reduce the environmental impact of energy generation and transportation. The introduction of water engines has the potential to influence global energy policies as nations strive to meet climate goals and cut carbon emissions. A viable, clean alternative to traditional engines may lead to significant policy changes. Governments could offer subsidies and tax incentives to support the development of hydrogen refueling infrastructure, encourage the production of green hydrogen, and promote consumer adoption of hydrogen-powered vehicles. Additional funding for research and development would also support the growth of this technology. Such measures could accelerate the shift to renewable energy, encouraging universal adoption and infrastructure expansion. For consumers, water engines promise a significantly improved driving experience. Unlike traditional internal combustion engines, which are noisy and prone to vibrations, water engines, like electric vehicles, provide a quieter, smoother ride. This reduces noise pollution and enhances driving comfort, making journeys more enjoyable. In terms of performance, water engines are comparable to electric vehicles, offering quick acceleration and instant torque. This responsiveness enhances driving enjoyment while maintaining environmental benefits. Furthermore, the water engine's clean energy output allows drivers to experience excellent performance without the guilt associated with traditional fuel sources. Cost savings are another potential advantage. As water engine technology matures and economies of scale are achieved, the initial cost of these vehicles is expected to decrease. Combined with possible government incentives and lower fuel costs, consumers may find water engine vehicles increasingly attractive from a financial perspective. Beyond automobiles, the applications of water engines extend to other industries. Tesla, for example, is exploring the use of this technology in aviation, where reducing carbon emissions is vital. Hydrogen-powered aircraft could revolutionize the aviation industry by offering the same environmental benefits as water engine cars. Maritime applications are also under consideration, with water engine-powered ships potentially reducing the environmental impact of global shipping and contributing to cleaner oceans and air. In heavy industries with high energy demands, water engines could offer a sustainable alternative, reducing reliance on fossil fuels and cutting emissions across sectors.